Hi everyone, as promised I'm recording this video to give you a very quick tutorial on fileIO in C and also using STL. Um, and of course, I mean you don't have to use the stuff that I'm showing you here. If you're already good at doing fileIO in C, go ahead and do it. You don't need to look at this. So here first I'm going to talk about STL a little bit, just show you a few examples, and then I'm going to talk about fileIO and how you read the stuff in it. So if you want to do the standard C version of the fileIO, you need to do stdio.h. Otherwise, if you're used to doing iostream, then you're fine. Go ahead and use that. String.h is pretty useful. It has functions that allow you to process strings of characters, especially the STR token, STR That's a function I'm going to show you later, how to basically parse tokens from your file. These are STL stuff, so note that if you're going to use data structure vector, you're going to say include vector. If you're going to use map, you're going to say include map. If you're going to use list, use include list, and there is no .h at the end of it. And use namespace std, you use that to avoid doing things like std map, etc. Right? So this is going to help you clean up the code and not write too much. All right, so here I'm defining something. And of course, I mean, the code that I'm showing you here is the code that I was trying to use to parse those, US road data. So I thought, I might as well just use that to show you how to manipulate these STL stuff and do fileIO. So you can define any structure. So this would be, struct city, and it has a name and the name of the state. These are a string of characters, and then you have, latitude, longitude data. Oh, by the way, one more thing. So the STL stuff are implemented in the C++ language. But that doesn't mean that you have to write your code in C++. You can write your code in C and use, vector and map and others with the C++ format. You just have to make sure that the compiler knows that it's a C++ code, the overall code, right? So if you're doing a Linux platform, for example, make sure that you do the .cpp extension if you're using the GCC compiler. If you're using G++, then you're fine. It's going to by default be C++, and it's not going to affect you. Okay, so basically, and here I'm showing you that I'm using the C style. I'm not defining a class city. I'm just doing a struct city. Now, if this struct city could be, in your case, could be a struct gate, and you could have the gate name, you could have the number of fan-ins, number of fan-outs as integers, you could have a vector or a list of edges that are incident to it, whatever, right? I mean, so basically this is a structure which has a number of components in it. And then if you want a vector of them. Now, a vector is a list data structure in which you want to have array access to. So you want to say, I want element number 23. I want element number 513, right? So so this is the vector. If you don't care about random access, if you don't want to do indexed access, then you would use a list. So in a list, you have a list is a collection of items, and if you want to visit everybody in the list, you're going to traverse the list from beginning to end. Okay, and so you can imagine that vector is implemented under the hood so that it can give you array access quickly, but then doing things like deleting stuff from the middle of it could be time consuming, for example. It might need to shift the stuff around to maintain an array type structure. That's not the case with list, right? I mean, in list, if you want to delete a stuff from the middle, then it's probably going to do it in order 1. But if you want to say give me element number 13 in this list, that's going to probably take 13 steps to get to that element from the beginning of the list. So you have to be careful what kind of data structures you want to use, and you can read online tutorials to do it. And by the way, there are tons of examples on the web, and even I've used vectors and maps many times, but even now if I want to write code, I end up doing a lot of searches on the web and looking up stuff using Google, and so on. All right, so basically what this is saying, and this is the standard boilerplate stuff in STL. You just say vector, and you put it in angle brackets, the type of stuff that you want to have. So this could be an int. So this would be a vector of integers. This could be vector of something more complicated like city. And here is my global variable city vector that I defined, and I'm going to add a stuff and search the stuff in this city vector. All right, now here I'm assuming that you have a buffer, a string of characters, and you're going to read a stuff from a file, put it in here, or ask the user to enter them on the terminal, and then I'm going to populate it with a struct city, a temp city variable. So strcpy does copy, so string copy, and you can find it in a string.h, and it basically is going to copy the string here into the name field of this temp city. And I'm going to probably do something else, reading the next value from a file to put in this token, or the user is going to put the token in there, and then I'm going to copy it to state. Then I'm going to read a floating point or a double value like 12.395 from this token into the x coordinate field of temp city. And if this is all gibberish to you, that's fine. It's probably because you have studied C++ and you haven't seen a scanf. People who have done C probably have seen a scanf in which you have a stuff without this part, right? So scanf stands for string scanf, and you're saying take this string, pretend that this is the input console that the user has entered the stuff, and just treat the rest as you would do with a scanf. All right, if you don't want to use scanf, you can use a2f as well. This is going to convert a string to a double, and you're just going to do the simple assignment. Now, once you have populated all the fields in temp city, then you can simply say to the vector data structure, so city vector, remember it was here, you can tell the city vector pushback. So pushback is going to add temp city to the end of the list. And if you want to learn about this stuff, you can basically go ahead and do a lot of search. So if you say STL vector in Google, then you're going to have references, from cplus.com, which is a very excellent, it's a very good website for looking up stuff. You might get sgi.com's STL stuff, which is the official handbook. You might get links to Stack Overflow. These are all excellent websites. So if you look at C++, basically it's going to tell you, give you the definition of the vector, then it's going to tell you member types. You probably don't need to worry about the member types, but then it's going to give you a bunch of member functions, and then you can basically use these to manipulate things and start working with them. And they provide a lot of examples too. Let me see. Down here they don't, but I'll show examples as we go through. So for example, I can click on size, and when you click on size, it's going to show you one example of how to use the size with the vector, and you can learn. So you're not going to learn STL unless you look at many examples on the web and read the code and try to adapt it to your needs. All right, so here we just added one element to it. Now I can imagine that you are reading 100 more elements from the file, or get it from the user. Once you've populated and once your vector is full, then you can basically traverse it, for example, by using one of these two methods that I'm showing you. So one way of traversing would be to just simply define an integer index, and then you're going to go up to cityvector.size. Okay, so size is that function that we just looked at on c++.com, and you get to treat it just like a vector, an array in C, right? So you can say temp city is going to be city vector I, and it's going to copy stuff. By the way, one more thing that I probably should mention is that pushback makes a copy of this temp city and adds it to the list. So if you end up modifying this, you're not going to modify the last element that was pushed back to the end of vector. Now, method 2 for traversing all the elements in the list in the vector is this. Again, this is might look gibberish, but just consider it to be standard boilerplate and stuff. So if you want to go through all the elements of a vector or a list or a map, what you do is you just say, I have an iterator of type vector city, right? So if you're dealing with list city, then this would just change list city or map city, whatever you have, but the rest is going to be quite similar. So you're going to say I have an iterator IT, and then IT is going to first be begin, right? So this function begin is going to give you the very first element in that vector, and as long as you haven't reached the end of the list, go ahead and do IT++. Now again, I mean this is some of the C++ stuff. So here when you say I++, you're doing an integer, right? Here when you say IT++, STL has defined how iterator is going to go to the next element. So under the hood, this might be dealing with pointers and sophisticated data structures. You don't care. These are all abstract ways of accessing things. And then star IT is going to be the actual element. So if you say temp city equal that, it's going to make a copy of the values of the fields of the temp city, which are the name and state and XY coordinate, and it's going to put it in there, right? So now these are not the only functions that you can use. Basically, you're probably going to have a find function somewhere, and then you have empty, which is going to empty the list. Operator bracket, you already saw that. Front is going to give you the front of the list. Back is going to give you the back of the list, and so on. You could do pop back, insert in the middle, which is probably going to be costly. But anyway, I mean, this shouldn't be too hard to follow. Then basically you can click on each and read the descriptions on it and so on. All right, let me give you another example. So let's take road segment, which is a structure. The road segment has a name, and then it has start and finish latitude, longitude, coordinates. Okay. Now, let's say for whatever reason you want to get quick access from the name of the road to its XY coordinates, right? So you may want to say, tell me what I-94 maps to, right? So now if I had only numbers to deal with, if I had numbered all the roads in the US from 1 to 5,000, then I wouldn't be using a map. I would be using a vector, right? But these are non-integers, so I'm going to use map. I can imagine that you might be using map to map the gate names to their index. Okay, so that's one of the things that you could do. For example, you could use map. All right, so here I'm saying that map is a data structure that the key, the index that you're going to use is going to be a string, and road segment is the actual data that you're going to have, and the global map, the global variable map, is going to be called road map. Now, here I have a temp of the road segments. This remained from the old code. So in the old code that I had, map was a long int. So I had a way of mapping that long int into mapping latitude longitude data into long int. For now, forget about it. So roadmap of ABC or I-94 equals temp road, and then you could add more. Then if you want to know if you do have the data I-94, then um, you wouldn't do things like this. You wouldn't do if roadmap of I-94 is not equal to roadmap.end. Okay, you wouldn't do this. And the reason you wouldn't do this is if you read the documentation carefully, it says if an item, if you try to access an item using the brackets and the item doesn't exist, it's going to create an empty element and add it with this key to the end. So this would not be a good way of accessing, of searching elements inside a map. The right way to do it is to use the function find. And again, if you look online, if you look up the find function for map, you're going to see that you're required to create an iterator variable, define an iterator variable, and then you're going to say it equal roadmap.find. Now, if the element isn't found, then it is going to point to end of roadmap. Otherwise, it's going to point to the element. And because it's a map, then map is going to have a dot first and dot second to access the actual data. So dot first is going to be the ABC or FGH that you have here, the key, and dot second is going to be the actual data that you have. Again, if this is gibberish, don't worry about it. Just use it as the template or use what you find in the examples, and that should get you through. All right, let's talk briefly about how to do fileIO. And let me add this brief comment too. That I mean, usually if you're going to deal with parsing an input file, you don't use C. You usually use things like Python or use a standard database formats and read it into a database and manipulate it. The reason I'm doing C here is, first of all, I don't want you to learn new languages like Python and so on just for this course. And number two, when you want to work in CAD companies, you have to do a little bit of this stuff. So it's a good idea to learn them now. And of course, I mean, I'm providing you with some hints that hopefully make it much easier for you to implement doing fileIO and stuff. All right, so for reading from text files, you usually define some buffer, and here I have defined a buffer of 1,000, and my input files are not going to have any lines that exceed 1,000 characters. And then you define file star, a file pointer cities, and here's how you open the file. You basically provide the file name here, and here this R here means that I'm going to read from the file. If for whatever reason you can't open the file, if you don't find it, for example, or whatever, then it's going to return null. You're going to report an error and get out. And then what you want to do is to read it line by line. So you read by using this function fgetS. And feel free to look up this fgetS online and read help on it. But essentially it's going to say from this file, read one line ending with the new line character at the end and put it in stemp. And the reason that you put this size of is just to make sure that you're not reading 2,000 characters, just in case that line involves more than 1,000 characters. You're not doing memory, invalid memory operations. And presumably you do some stuff with this first line that you read. And then you could say, why, as long as you haven't reached the end of the file, then go ahead and read, another line from the file. And fgetS is going to return null, the null pointer, if you have reached the end of the file or for whatever reason it can't read the next line. And if that's the case, you break out of this while loop and you're done with reading the file. Now, when you read that line of the text, a very useful function is STR Token. STR Token is going to say, I want to parse the fields of this line of text one by one with these delimiter characters in between them. Okay, so basically if you have something like ABC space comma and then in parentheses DE, close parenthesis, FG equal 2. And if you use STR token, you're going to get ABC, and it's going to skip over all of this stuff, and then it's going to return DE, skip over this stuff, return FG, and then return 2. Okay, very useful function. So, and of course, I mean, let me show you what you're going to encounter in your programming assignment and the file that you have. So this is part of the file that you have. So here, for example, you want to be able to, and I apologize if you can't read. Nah, maybe I can just increase the font size to, yeah. So, here you probably want to read this and then discard the space and the equal, and then you want to read this and interpret it as the gate type. Then again, discard this. This would be the next element that you read. Discard these. This would be the next. This whole thing is going to be the next element that you're going to read. And then you're going to do processing by looking up the name of the gate and so on. All right. So, but in this example that I took from the U.S. roads parsing, this was the format of the file that I had. So I had these elements, and then the way that you use STR token is this. The very first time that you want to use it on your buffer, you provide the buffer as the first parameter, and then the list of delimiters here. Now, the return is going to be a pointer to a character string, and if that pointer is null, it means that either you have reached the end of the string, or the string only had these delimiter characters. No tokens to read, hence you're done with processing that particular line. You're done. Otherwise, this token is going to have the first element, so it's going to return a string which only contains this. Now, subsequent calls to it for this line of buffer are going to use a null pointer as the first string. So STR token is going to remember the rest of this string, and it's going to process them. And every time that you call STR token, the character string that you're going to return is going to be first a string containing this, then a string containing this, and so on and so forth, and you would process them and populate your gate or edges or cities, roads, whatever that you have in the data, and then you would add that stuff into vectors or maps and so on. And finally, once you're done with this loop, once you've reached the end of the file, you just go ahead and close the file pointer which you opened up here, right? Now, if you guys are more comfortable with doing the C++ version of the fileIO, which does stdio or iostream, fstream, and so on, go ahead and use them. I don't have any particular reasons to force you to use the C version of it. If you don't use STR token and instead use other stuff, I mean, I know there are things like you could do fscanf, and then the string could be %s equal another %s, and then give a specific formats, and then a scanf is going to take care of a lot of STR token, although I think it's not as reliable as doing STR token. But I mean, feel free whatever method that suits you and your preferences. Okay, all right, hopefully this should give you enough background to start doing the programming assignment. But the important thing is not to panic. I mean, if you have questions, if it looks too big, come talk to me, come talk to the TA, and hopefully we can help you get it done. And one of the reasons that I set deadlines for phase 1, phase 2, phase 3 is to get you working and get you to do this stuff and not postpone everything to the last minutes. All right, good luck.